Good morning, everybody. Today we shall see fifth experiment in Power System Simulation Lab, which is Zbus formation using Zbus building algorithm. Zbus building algorithm already we have seen in detail in Power System Analysis 2 subject. Theoretically, we have done the problems. Now we'll see how to implement the same using a program. So enter the input data in matrix form. As usual, we start with clear instruction. Clear instruction will clear all the variables used so far. Then in the next line you have Z. Z is equal to input, enter the given data in matrix form. And this is the format that is being expected. Element number from bus to bus ZB. And for the second element again, element number from bus to bus ZB, and it continues as long as the number of elements are present in the given data. So element number, say that is nothing but the branch number. That branch number exists between two buses. So that must be given, that is from bus and to bus. Between those two buses it will be present, and that element has got the corresponding impedance. ZB is nothing but branch impedance. So in this way, for all the elements, row wise the data will be given. Then m comma n is equal to size of z. This is to find the size of the z matrix that will be done in the previous step. In the previous step, the input will be given. After the input will be given, size of the z matrix will be found, where m will be the number of rows, n will be the number of columns of your z matrix. Then next part is initializing the ZBus. Again, please remember, you are giving the prefix as percentage symbol, which means this is a comment and it will not be compiled. So ZBus is equal to null. So you are initializing the ZBus as a null matrix. Then we are defining a variable x which is equal to 0. Initialize the variable x and it will be equal to 0, and in the future it will get updated in the next few lines. For I is equal to 1 to m. You very well know that m is nothing but the number of rows of Z matrix. So I is going to vary from 1 to total number of rows of Z matrix. If, for example, Z is having 5 rows, I is going to vary from 1 to 5. For I varying from 1 to 5, j is equal to I. We are taking another variable j, and that j will always be equal to I. Then r comma c is equal to size of ZBus. ZBus matrix eventually will be appearing as and when the algorithm progresses stage by stage. So r comma c defines the number of rows and columns of ZBus. M comma n is for Z input matrix. For ZBus matrix, r defines the number of rows, c defines the number of columns. And we are defining another variable from is equal to z of I comma 2. That means access the second column elements of Z matrix and save it into from. 2 is equal to z of I comma 3. Access the third column elements of Z and save it into 2. And access the fourth column elements of Z and save it into ZB. Capital N is equal to max of from comma 2. So you are having a matrix from, which is a column matrix. You are having 2 matrix, which is another column matrix. So compare the respective elements in from and to, and pick up the maximum value. That will be nothing but capital M. If you pick up the minimum value, that will be reference. So this is how you find N and reference. Then step 1, type 1 modification. We assume that we do type 1 modification initially. I don't have to repeat what is type 1, type 2, type 3 and type 4. Already you have seen this in theory. But the approach is quite different. The solving approach is quite different here in the program. If the variable n is greater than x and reference is equal to 0, your ZBus will be equal to, the first cell element will be ZBus, second element will be zeros of r comma 1, and in the next row you are having zeros of 1 comma c, and then last element will be ZB, and x will be updated to capital N. So if you compare it with the theoretical part, there you have Zik equal to Zki is equal to 0, and zkk is equal to zb. So zki zik equal to 0 is denoted by zeros of r comma 1 and zeros of 1 comma c. Zkk is equal to zb is denoted by this zb. You have to compare. Once this is done, x will be equal to n, and then it says continue, and this ends the subroutine for type 1. Then we go to the next subroutine where type 2 modification is carried out. If n is greater than x and reference is a non-zero value, then only type 2 modification will be carried out. And the zbus for that will be equal to first cell is zbus, and then first row second column will be zbus of colon comma reference. Second row first element will be zbus of reference comma colon, and the last element will be zb plus zbus of reference comma reference, and then x is equal to capital N, continue, end. Anyway, once we see the illustration, you will be able to get a better idea. At this particular stage, you'll not be able to understand anything. Then we go to type 3 modification. If n is less than or equal to x and reference is a zero value, then zbus will be equal to zbus minus 1 over zbus of n comma n plus zb, zbus of colon comma n into zbus of n comma colon. Continue, end. Then we go for type 4 modification. Corresponding condition is if n value is less than or equal to x and reference is a non-zero value, then this is the zbus. Anyway, I don't have to read out this, you'll understand this in illustration. Continue, end, end. This ends the program. Since it involves a lot of variables and conditions here, let us see the illustration, then you'll get a better idea. So I've taken a simple problem as an example here. So whatever is marked in brown here are the lines of the program, and this is the execution, whichever is marked in black is the execution. So initially what we have to do is input z, en, fb, tb, zb, as already I told you. So let us consider element number 1. I'll consider element number 1 between 1 and 0. 1 is nothing but the bus 1 that I'm showing here, and this is the ground, which is bus 0, and this element of 0.1j is considered as first element. So in the standard format, I write 1 as element number, from bus is 1, to bus is 0, corresponding impedance is 0.1j or 0.1i. Then second element will be 1, 2, 0.6i. So I'm referring to this one, 0.6i. Then third element is between 2 and 0. Between 2 and 0, this is the third element. Fourth element is between 2 and 3. Between 2 and 3 is the fourth element. And then fifth element is between 3 and 1, which is 0.4i. So having given the network, this is how you are going to input the data. Once you input the data, this is how the Z matrix will be ready. So here, next set of instruction is m comma n is equal to size of Z. So we are trying to calculate the size of the Z matrix. So as you can see here clearly, 5 rows are there, 4 columns are there. So size of the Z matrix will be 5 cross 4, and m is the variable dedicated for rows. So m is equal to 5, n is equal to 4. So we have identified two variables, m and n. Then x is equal to 0 in the program initialization, and zbus basically is null matrix, which is 0 cross 0. That is what is happening here. Next set of lines, it's very crucial to understand the rest of the program. For I varying from 1 to m, j is equal to I. So I is going to vary from 1 to 5 because m is 5 and j is equal to I. That means whenever I is 1, j is also 1. Whenever I is 2, j is 2. Whenever I is 3, j is 3. Like this, it continues up to 5. And I have rewritten Z matrix here for reference purpose. Then R comma C is equal to size of Z bus. So here size of Z bus initially is 0. So your R is 0, C is also 0. R represents rows of Z bus matrix. C represents columns of Z bus matrix. Then from 2 and ZB, from your Z matrix, they are segregated. So second column of your Z matrix is saved into from. So this is the second column, as you can see, 1, 1, 2, 2, 3. This is the second column. Then third column is saved into 2. Third column is 02031. This is the third column that is saved into 2. Then z of I comma 4. Fourth column is saved into zb. This is the fourth column. 0.1i, 0.6, 0.1i, 0.4i, 0.4i. This is saved into another matrix which is called as zb. Now you can see the comparison. How to find the capital N and reference value. So here I have rewritten from matrix, to matrix and ZB matrix. So substitution is shown here. So here you can see from to and then N reference and ZB. Now we'll see how to get N and reference. So to get N and reference, you'll have to compare the elements of from and to. So let us go to the first line here. See, from is 1, 2 is 0. So here maximum among them is 1, minimum is 0. So capital N will be 1, reference will be 0. Similarly, go to the second line. From is 1, 2 is 2. So reference will be 1, capital N will be 2. Maximum among the 2 will be N, minimum among the 2 will be reference. So go to the third row. From is 2, 2 is 0. So capital N will be 2, reference will be 0. Then you are having fourth row, which is from is 2, 2 is 3. 2 is 3. So capital N is 3, reference value is 2. From is 3 and 2 is 1 in the last row. So capital N is 3, reference value is 1 because maximum is 3, minimum is 1. And ZB matrix is also repeated here. This is how we are going to get capital N and as well as reference value. Now let us see how the program gets executed here. So coming to the program, we'll have to identify when type 1 will be carried out, then type 2, type 3 and type 4. If capital N is greater than X and reference is 0 value, type 1 will be executed. If capital N is greater than X and reference is non-zero value, type 2 will be executed. If N is less than or equal to X and reference is 0, type 3 will be executed. And if N is less than or equal to X and reference is a non-zero value, type 4 will be executed. So you are just going to compare N, X and reference values here. So same table I am going to repeat here once again. See this last table from to N reference ZB, this table is getting repeated here. So the same table is there. Now I start with the first row. J is equal to 1. When I is 1, J is 1, X is 0 initially. Now just try to check for the condition whether it comes in which type. So here in this particular first row, N is 1, X is 0, reference is 0. So N is now greater than X and reference is a 0 value. So whenever N is greater than X and reference is 0 value, it should undergo type 1 modification. So type 1 will be executed. So here I have shown the type 1 modification. So when it comes to type 1 modification, blindly substitute the variables. As of now, Zbus is not present. So R is 0, C is 0. And in this particular case, as of now, reference is 0, capital N is 1. Substitute the corresponding variables, you will be getting the Zbus matrix. And then X will be equal to capital N in this particular step. So capital N was 1. So X is equal to 1. It will return from type 1. Go to the second line. In second line, as of now, X is already updated to 1 from the previous step. Then here you are having N and reference values. So you can check that N is greater than X, but reference is non-zero value. So when N is greater than X and reference is non-zero value, it should undergo type 2 modification. So let us go to type 2. So as of now, already Zbus contains one element. So R is 1, C is 1. Reference is 1 and N is 2 for the second row. Substitute all these variables, you will be getting the Zbus matrix. As you know, whenever you perform type 1 and type 2 modification, size of Zbus increases by 1. So that is what has happened here. Earlier in the previous step, Zbus matrix was 1 cross 1. Now it has become 2 cross 2. And in this case also, X will be updated to capital N. Capital N here in this step is 2. So X is equal to 2. It will return from the subroutine. Now let us go to the third row. In the third row, J is equal to 3, X is equal to 2 and from to n and reference are there. Now again compare the variables. So what is happening here? N and x are equal here, and reference is 0 value. So the it should undergo type 3 modification, because whenever n is less than or equal to x and reference is a 0 value, it should undergo type 3 modification. So I'm showing type 3 modification here. So as of now your ZBus size is 2 cross 2, so R is 2, C is 2, and in this row, in this particular row, reference is 0, capital N is 2. Substitute all the variables in the given formula, and you'll be getting, after simplification, you'll be getting the following ZBus, and it will return, and again it will go to fourth row. In the fourth row, once again you will check for the condition. N is basically greater than x and reference is a non-zero value, so type 2 is getting repeated once again. Similarly, in the fourth row, check for the condition, whether it falls under which type, substitute the variables, and then find the ZBus matrix. So this is how we are going to execute the program on ZBus matrix, which is quite different from the theoretical approach. So this finishes experiment number 5.